What's up, guys? Welcome back to the channel. Today we're going to be learning how to solve problems using exponent laws in order to solve for a variable base by Dr. Daniel and
Matthew.
all right, so let's get into it. A few vocabulary words we'll be using in this video. All right, first vocabulary word we'll be using is exponent. How many times a base is multiplied times itself?
All right, for the second word, we'll be using base. Number or the variable being raised to a power.
For our third word, we'll be using the simplified form. No negative and all like terms being combined.
For the fourth, we'll be using quotient of power rule. When multiplying base, add exponents.
And for our final, we'll be using quotient of the power rule. When you divide the sum base and subtract the exponents.
And the last one would be simplified.
Okay, so for problem one, welcome back, guys. So first of all, we have problem uno. For problem one, our problem will be x to the power of 4 times x to the power of 7. So now, okay, let me just rewrite this one real quick. Sorry about that. 7. Oh. So first we have to identify the bases, which we could tell is x. And we notice that both terms have the same base. So those would be our bases. The numbers are 4 and 7. And these are the exponents, as you can see here. And these help us tell how many times the base will be multiplied by itself. So, since we are multiplying both of these by the same base, we have to apply the product of power rules from earlier. Okay, so the rule states that when you multiply the expressions with the same base, you have to add the exponents. So the exponents being 4 and 7 comes out to 11. So our final answer from this would be, let me erase this. Give me a moment, I'm sorry. Our final answer after adding the exponents using the product of power rule. So our final product using the rule would be x to the power of 11. This is already in a simplified form because there is no negative exponents and there's nothing else left to combine. So this problem is pretty easy. So now we know that problem 1 worked. All right, so for our second problem number 2, we have sorry about that. It's a little, board's still a little wet. Okay, so we have a to the power of 9 divided by a to the power of 3. Now, a short explanation on how we're going to solve this is we have to identify the base. We know the base in both of these is 8, right? So, okay, so a is both in the numerator and denominator. The exponents are 9 and 3. Because we're dividing powers with the same base, we have to use the quotient of powers rule. Now, all we need to write what's left is just 9 subtracted by 3 equals 6. So our final answer would be a to the power of 6. So a to the power of 6 would be our final answer for this one. This expression is in simplified form because there are no exponents that are negative and we have no extra factors. So this is our medium problem. Now let's get on to our more harder questions answered by Matthew, number 3 and number 4.
All right, for our third problem, we'll be now working with Dr. Matthew, which is me. Thank you for the last 2 problems, Daniel. And we would have to simplify 3x to the power of 2, y to the power of negative 3 squared by 2. So as you can see, this entire expression is inside the parentheses and is being raised to an exponent, which means I need to use the power of a power rule because it is in parentheses. So the power of a power rule is when a power is raised to another power, you multiply the exponents. So now we would have to apply this rule to each factor inside the parentheses. So now this 3 with the x squared would be 3 to the power, wait, my bad. This would equal 9 because 3 to the power 2 would be 3 times 3 and it equals the 9. Okay, for our second step, we would have to be raising x squared to the power of 2, which becomes x to the power of 2 times that would equal x fourth. Okay, for our third step, which is our final, we would have to raise the power of 2 for y to the negative third. And how that would look like would be y to the negative 3, as you can see there, times 2, which would equal y to the negative 6. After we've handled all the coefficients, now we would be applying the power of rule expression to everything we've done before that. So how that would look like would be 9x to the power of 4, and then it would be y to the negative 6. Okay, the expression is not yet in simplified form because it has a negative exponent, as you can see right here. So I apply the negative exponent rule, which states that a negative exponent means the base moves to the denominator with a positive exponent. Moving y to the negative 6 to the denominator gives 9x4 over y6. Now that would be our final answer. Now we'll be moving into our last equation, which would be a real-world application. Okay, so our story is about a science club that is trying to grow bacteria for an experiment. The experiment starts off with a base amount of 5 bacteria samples. So we're going to write down 5. Each sample grows with a following an exponential pattern. The growth factor is written as parentheses. Well, we're going to times it, right? Okay, so we're going to put parentheses 2 to the third, where the t represents, forgot to write the t, my bad. The t represents the numbers of hours. Cut. At the same time, some bacteria are being moved for testing at the same rate of 2. So we would have to divide it, and it'd be 2 to the t, which represents the time. Alright, for our first step, we would have to identify the structures of the expressions. So number 5 would be a coefficient. The base involved in the exponential growth would be 2, and the variable t, which represents time in hours. And I also notice a power raised to another power, which means I will use the power of a rule. My bad. The power of a power rule states that when a power is raised to another power, you multiply the exponents. And the exponents would be 2, 3, parentheses. You put t on the outside, which represents hour, as I said before, and you write down 2 and then 3t. The expression becomes 5 times 2, 3t divided by 2t when done. Okay, resolve this. Okay, for our third step, we would have to apply the quotient of powers rule. I am dividing 2 exponential expressions with the same base, which is 2. The quotient of powers rule says to subtract the exponents. So now I'm going to write the full expression, which would be 2, 3 divided by 2t, which would equal 2 before, then it would be 3t, and then that. Okay, and our final answer would be 2t because this counts as a 1. Now we simplify it once again. We'll bring back the 5 from earlier. Sorry about that. And we'll times it by 2 by t, 2t. And then this is already in simplified form because all exponents are positive. Like bases have been combined and no exponent rules remain to apply. Okay, also when we combine all the exponent rules, it helps show the overall growth and the patterns that happen throughout the expressions more clearly. And it makes it easier to understand how time affects the total bacterial numbers.
All right, thank you guys for watching. We hoped you learned something out of this video. Like and subscribe and stay blessed.
Stay blessed, guys.
Deuces.
Deuces.